Dear student, today we will discuss about the communication system. So, what is the communication basics of the communication systems? Communication deals with principle of transferring information from one place to another place. It involves transmission and reception and processing of information between these two locations. The source could be continuous or as in the case of analog communication and a discrete signal as in the case of digital communication system. So basically two types of communication. First one is analog communication and second one is digital communication. Short distance transmission of information is called baseband transmission. For long distance transmission, information has to be impressed upon an high frequency component to be able to reach the reception end of communication system. The high frequency component is termed as a carrier signals and the entire process is called the modulation technique. So very important role of modulation technique in the communication system. So what is the need for modulation? To translate the frequency of a low pass signal to a higher band so that a spectrum of the transmitted band pass signal match the band pass characteristics of the channel. For efficient transmission, it has been found that the antenna dimension has to be of the same order of magnitude as the wavelength of the signal being transmitted. Since C equal to F for a typical low frequency signal of 2 kHz, the wavelength work out to be 150 km. Even assuming the height of the antenna half the wavelength, so height of antenna will be equal to lambda upon 2, the height work out of 75 km, which is impracticable for this wavelength. To enable transmission of a signal from several message sources simultaneously through a single channel employing frequency division multiplexing FDM, to improve noise and interference unity in the transmission over a noise channel by expanding the bandwidth of the transmitted signal. What is the frequency translation in the communication system? The modulation process shifts the modulating frequency to a higher frequency, which in turn depend on the carrier frequency, thus producing upper and lower side bands. Hence, signals are up converted from low frequency to high frequencies and down converted from high frequencies to low frequency in the receiver. The process of converting a frequency or a band of frequencies to another location in the frequency spectrum is called frequency translation. So this is the frequency translation. What is the type of modulation? So depending on whether the amplitude, frequency or phase of the carrier is varied in accordance with the modulation signal, we classify the modulation as first one is amplitude modulation, AM modulation. Second one frequency modulation or FM modulation. Third one is phase modulation or PM modulation. The method of converting information into a pulse form and then transmitted it over a long distance is called pulse modulation technique. So transmitter is the part of the transmitting or communication system. So in transmitter, the message as it arrives may not be suitable for direct transmission. It may be voice signals, music signal, picture signal, or data signals. The signals which are not of electrical natures have to be converted into electrical signals. This is the role of transmitters here, and typical block diagram of transmitter as illustrated in below diagram. So there are different networks: carrier, crystal, oscillators network, buffer amplifier, and also voltage and power amplifier here, and also electrical transducer and band pass filter, pre-amplifier and voltage and power amplifier. So there are many different networks in which have the different functions in transmitter system. Next is the receiver. This is the also part of the communication system. A receiver is meant to receive the electromagnetic signal which carries the information. It is tuned to receive the required information at a predetermined frequency. The output of the receiver is usually feed into a transducer, which convert the information into understandable signals. So here that is the block diagram of the receiver. Here also many more networks which have the different functions such as RE amplifier, mixers, local oscillators, intermediate frequency amplifier, demodulator, and also audio voltage and power amplifier. And also here a speaker work as a load in this receiver system. So this is the block diagram of the receiver. Next technique is the multiplexing. So what is the multiplexing technique in communication system? When it is required to transmit more signals on the same channels, baseband transmission fail, as in the case of audio signal being broadcast from different stations on the same channels. To encounter this problem, either frequency division multiplexing FDM or TDM time division multiplexing is employed. This method of transmitting several channels simultaneously is known as frequency division multiplexing FDM. In time division multiplexing or TDM, several signals are transmitted over a time interval. Each signal is allotted a time slot and its gates repeated cyclically. The only difference compared to FDM is that the signal are to be sampled before sending. What is the signals in what is the role of signal in communication system or communication field? So any function that carries information that is the signal. So how a parameter vary with another parameters, and signal will be dealing with signals with time or frequency as an independent variables. So that is the signals. We can classify signal as first continuous and discrete signal, second one casual and non-casual signal, even and odd signals, deterministic and random signal, real and complex signal, and also energy and power type signals. So there are different types of signals. This is the discrete signals which show the waveform in the form of the discrete pulse, and this is the continuous signals, which is the sinusoidal signals, and in which the amplitude is vary with the time in this continuous signals. And this is also a casual signals, and this may be and these are the even and odd signals. And this is the special type signal, which is represented by sin ct equal to sin pi t upon pi t. So here in this signal, amplitude is continuously vary with the time, and this is also example of signals, and signal st equal to will be 1 if t is greater than 0 and equal to -1 then t is less than 0. So these are the signals, and this is the impulse of delta signals. So first is the impulse signals and second is the delta signals. So delta signals integration of delta t minus infinity to infinity equal to 1, and impulse signal minus infinity vt delta t dt equal to vt. So these are the examples of impulse of delta signals. Next, the classification of systems. So first, discrete time and continuous time systems. Second one, time invariant and time varying systems. Third one is casual and non-casual systems. Next one is instantaneous and dynamic systems. And last is stable and unstable system. So these are the some systems. Next, Fourier series and transform. So what is the Fourier series? Any periodic of function of time xt having a fundamental period capital T and frequency 1 upon t can be represented as an infinite series of sinusoidal waveform of fundamental and its harmonic frequency. So if function is xt, so its Fourier series is given by this equation x t equal to a naught plus summation of n equal to 1 to infinite a n cos 2 pi f n t plus summation of n equal to 1 to infinite bn sin 2 pi f n t. So this is the Fourier series representation xt, where a naught is the 1 upon t integration minus t by 2 to t by 2 xt dt, and the a n equal to 2 t integration of minus t by 2 to t by 2 xt cos 2 pi nt upon t dt, and the value of Vn equal to 1 upon 2 upon t xt sin 2 pi nt dt. Next one, Fourier transform. To represent a periodic function, Fourier transform is used. Unlike Fourier series, this representation will be continuous in frequency domain. So it is given by Fourier transform x f equal to integration from minus infinity to infinity xt to the power minus j 2 pi ft dt. Also, xt can be obtained from xf as xt equal to minus infinity to infinity integration of xf e to the power j 2 pi ft df. So this is the value of xt in the form of frequency domain. Next term is the parameter is transform of Laplace transform. So what is the Laplace transform? Laplace transform convert time domain signal into frequency domain. A plane called a plane having sigma as the real part and omega as the imaginary part. So Laplace transform is given by the expression x omega equal to integration from minus infinity to infinity of xt e to the power minus xt dt, and also capital X omega equal to integration from minus infinity to infinity xt e to the power minus sigma plus j omega t dt. And the inverse Laplace transform is given by xt equal to 1 upon 2 pi j integration of minus infinity to infinity capital X S equal st ds. So this is the inverse Laplace transform. Next one is the Z transform. A Z transform is a polar representation compared to a rectangular representation in Laplace transform. Z transform of a function xt is given by xz equal to summation of x and z or minus n. Inverse Z transformer is given by x n equal to 1 upon z into xz. So in Z transform, term ROC defined as region of convergence ROC, where the Z transform of a function has finite value. So now we will discuss about the amplitude modulation or AM modulation. So amplitude of the carrier is changed in proportional to the instantaneous amplitude of a massive signals. And carrier frequency must be relatively higher than the message frequency. This is the in the amplitude modulation system. And modulation index M is the ratio of modulating voltage to carrier voltage. and in the form of percentage of modulation equal to m into 100 percentage. So this is the percentage of modulation. In amplitude modulation, so this is the AM envelope. The waveform first is show the modulating signal. This is the low frequency signal. And second waveform show the carrier signals which have the high frequency as compared to modulating signal frequency. And third one is the amplitude modulated resulting waveform. So this is the technique of amplitude modulation system in which different signals used, and after modulation the resultant waveform of amplitude modulated is received here. Now what is the frequency spectrum of AM wave or amplitude modulated wave? So there are some frequency spectrum. Here one is the carrier frequency signal and FC, and other is upper sideband, and second is lower sideband. Upper sideband signals equal to MEC upon 2, and lower side band signals MEC upon 2 also. So these are the frequency spectrum of AM waves. And this graph show the power spectrum of the amplitude modulated system. So in power spectrum, power versus frequency graphs drawn here. So here also carrier power EC square upon 2R and upper sideband carrier power equal to M square PC upon 4, and also lower sideband power equal to M square PC upon 4. So there is the representation of power spectrum of AM system. There are other also AM system. So suppressed carrier system is the AM system, and also double sideband systems, single sideband systems, single sideband with pilot carriers, and independent sideband system, and also vestigial sideband VSB system are example of AM systems. These are the example of other AM systems. So in this different waveforms, the A waveform is the modulating signals, and B is the AM wave, amplitude modulated wave, and C is the suppressed carrier waveforms, and D is the suppressed carrier single sideband waveform. So there are AM waveform for AM, DSB, and SSB signals. Single sideband. So what is the advantage of single sideband? First one is lesser power consumption in single sideband. Conversion of bandwidth, conservation of bandwidth. This is also advantage of single sideband. And noise reduction in single sideband, and less fading. So these are the some advantage of single sideband. But we have some disadvantage of single sideband system. So disadvantage here, it requires complex receivers. And at the receiver, coherent carriers has to be generated. And next disadvantage is in case of pilot carrier at the receiver, and it has to be boosted properly. Next, AM modulators, amplitude modulation modulators. So there are different types of modulators which is used in AM system. So first one is the square law modulators. Second one is switching modulators. Third one is transistor modulators. And transistor modulators also classified in three types. One is low level modulators, second is medium levels, and third one is high level modulators. And also there are different types of modulators. Balance modulators and balance modulators also classified in four type modulators. First one is balance ring modulators, second one balance bridge modulators, third one transistor balance modulators, and fourth one is field effect transistor balance modulators. So these are the types of modulators. And next one is single sideband generation. So for the single sideband or SSB generation, there are different methods. With the help of different methods, we can generate the SSB signal. So first method is the filter method for the SSB generation. Second is the phase shift method, and third one is the third method for the SSB generation. And next one is the demodulators, distortion, and receptions in modulation system. So amplitude modulation demodulators are or demodulators are: first one is rectifier detectors, second one is envelope detectors. So these are the two types of AM demodulators. Next one, detector distortions. So there are diagonal peak clipping distortion. Second one is negative peak clipping distortion. And also SSB reception. So for the single sideband reception, first is the coherent detection method, and second one is the reception with pilot carriers. This is the AM transmitter block diagram in which there are different networks and different device used for the AM transmitters purpose. So RF carrier oscillators, also buffer amplifier and carrier drivers, modulators, band pass filters, antenna, coupling network, band pass filter, linear final power amplifier, and linear intermediate power amplifier, band pass filter, and modulating signal source and pre-amplifier. So there are the different devices that recombine and made a AM transmitters. And another block diagram for the double sideband transmitter. So there are different also block diagrams of different networks. So this is a high level DSVFC transmitters. And next one is the Ssb transmitters. So in Ssb suppressed carrier transmitter, band pass filter is used to remove the other sidebands. So here low frequency crystal oscillators and also USB crystal and lower sideband crystal also connected to the low frequency crystal oscillator, and here is a audio input that applied to the sideband pass filter, and output of this sideband pass filter applied to the balance mixer, and also a signal mix here balance mixer by the crystal oscillator, that is the high frequency signals, and output of the balance mixer is applied to the linear power amplifier, and then this signal applied to the matching network, and matching network transmit the signal with the help of antenna to the free space. So this is the SSB transmitter. Next one is the phase shift method for the generation of SSB. So this block diagram show the phase shift method for the SSB generation. There are also a 90-degree phase shift network used. That is the shifting the phase shift 90 degree in the audio input signals. And there are also two balance modulators, and one is crystal oscillator. And output of these balance modulator is summing in the summing amplifier, and output of this summing amplifier applied to the linear power amplifier, and that linear power amplifier output is applied to the matching network, and this matching network transmit the signal in the free space with the help of antenna. And also the generation of SSB transmitter with pilot carrier. So here is in this diagram, the balance modulator is fed by the two input signal. One is the audio input, second is the carrier oscillator, that is the generate carrier signal, and output of balance modulator applied to the USB filter, which have the 100 to 104 kilohertz frequency range, and output of the carrier oscillator applied to the carrier injection attenuator. The output of this carrier injection attenuator is the 100 kilohertz, and this is the applied to the summing network, and also USB filter output is also applied to the summing network. The output of this summing network feed to the balance modulator, this is the mixer. In this mixer, a carrier signal also mix here, that is generated by the carrier oscillators, which have the frequency of 2900 kilohertz. So the output of this mixer is balance band pass filter, which have the 3000 to 3004 kilohertz frequency range, and output of this band pass filter signals is applied to the linear power amplifier, and this linear power amplifier transmit the signal through to free space with the help of antenna. So this is the SSB transmitter with pilot carriers. Next one is the AM receiver, amplitude modulation receiver. This is the super heterodyne receiver diagram. So here the signal is received with the help of antenna, and this signal feed to the RF radio frequency amplifier, and also A high frequency signal which is generated by local oscillator is also applied to the RF amplifier. The output of amplifier and local oscillator signal is applied to the mixer, and the output of mixer applied to the intermediate frequency amplifier, and then this signal of the IF amplifier applied to the detector, and here is the automatic volume control device, and the output of detector here is audio frequency amplifier. This audio frequency amplifier receive the signal from the detector and transmit to this signal to the speaker. So this is the AM receiver system. That is the single sideband pilot receiver, in which a receiver network and upper sideband filters and pilot carrier filters also in this diagram, and also a valence modulator product demodulator, and finally a low pass filter which pass the low frequency signal, or which have the frequency range 0 to 4 kilohertz. The output of low pass filter is the audio output signal. So this is the SSB pilot receivers. The signal is received at the low pass filter output in audio form. And this diagram also represents the communication receiver diagram. And here also different networks. So signal is received from the help with the help of antenna and applied to the RF amplifier, which have the frequency 1.5 megahertz. And this signal applied to the first mixer, and a first IF amplifier also generate the signal to first IF filter. That frequency is the 10.7 megahertz, and this signal applied to the second mixer, and also in second mixer a second oscillator, crystal oscillator, which is generate the high frequency signal and applied to the signal second mixer, and the output of first mixer is the 160.7 megahertz, and this signal applied to the frequency tripler amplifier, and output of second mixer applied to the second IF, which have the frequency 465 kilohertz, and also a AGC detector and amplifier also used for AGC to RF amplifier, and second IF filter saturating the amplifier, and output of this amplifier is detector, and output of detector applied to the AF amplifier, and this AF amplifier pass the signal to the speakers, and there are different blocks and different functions of each blocks here. So this is the diagram of the communication receivers. There are different parameters in the receivers. So first is the selectivity parameter, second one is the sensitivity, third one is the dynamic range, fourth one is the fidelity, and next one is the bandwidth, and last one is the noise temperature and equivalent noise temperature. So these are some parameters which is the receiver parameters. this is the diagram also post loop in which two low pass filter used, and one signal is used as a carrier signal YT, which is signal is applied to two multipliers, and in these two multipliers a 90-degree phase shift also mixing, and the output of two low pass filter, one is IT and second output of low pass filter is QT, and these two outputs are again multiplied in the product network, and output of these product network to apply to the loop filter, or output of this loop filter applied to the voltage control oscillator, and this output of VCO is again applied to the two multipliers. So this is the post-task loop for the modulation system. These are the some reference books for these topics. First one is Principle of Communication by Topsili. Second one is the Analog Communication by Birla and Sharma. There are also some multi-choice questions. So we will discuss these multi-choice questions one by one. First question, in frequency modulation. So option A, amplitude of the carrier remains same. Option B, frequency of the carrier varies in accordance with the modulating signals. Option C, the number of sideband are infinite. Option D, all of the above. So here correct answer is the option D, because in FM modulation system, amplitude of the carrier remains same, frequency of the carrier varies in accordance with the modulating signals, and the number of sidebands are infinite. So correct answer is all of the above, which is occurs in the frequency modulation system. Next one is frequency deviation in FM is option A, change in carrier frequency to the frequency above and below the center frequency. Option B, formation of sidebands. Option C, the variation of the instantaneous carrier frequency in proportion to the modulating signals, all of the above. So correct answer here, option D, because for the frequency deviation, these all options A, B, C are correct here. So correct answer is option D. Next question, carrier showing a defined edge. Option A, the total variation in frequency from the lowest to the highest point. Option B, frequency deviation above or below the carrier frequency. Option C, width of the sideband. And option D, none of the above. So here correct answer is option A, for the carrier swing is defined as the total variation in frequency from the lowest to the highest points. Next one, the amount of frequency deviation in FM signal depend on option A, amplitude of the modulating signal. Option B, carrier frequency. Option C, modulating frequency. Option D, transmitter amplifier. So here amount of frequency deviation in FM signal depend on the amplitude of the modulating signal. So correct answer is option A here. Next question, drawbacks of using direct method of generation of FM signal are: option A does not give high stability to FM signal frequency. Option B, distorted FM signal is generated due to harmonic of modulating signals. C, cannot be used for high power FM generation. Option D, both A and B. So correct answer here option D, in which A and option D is correct here. And next, advantage of using direct method for a generation of FM signal is: option A, it's give high stability to FM signal frequency. Option B, distortion free FM signal is generated. Option C, high power FM generation is possible. Option D, none of the above. So correct answer is option C. Advantage of using direct method for generating of AM signal is the high power FM generation is possible. So option C is correct answer. Next question, the drawback of tuned radio receivers are: option A, oscillate at high frequencies. Option B, selectivity is poor. Option C, bandwidth of the TRF receiver varies with incoming frequency. Option D, all of the above. So correct answer here, option D. It means drawbacks of tuned radio receivers are: oscillator at high frequency, this is the drawback. Selectivity is poor, this is also drawback. And bandwidth of TRF receiver varies with incoming frequency. So this is also drawback of the tuned receiver. Now next question, sensitivity is defined as: option A, ability of receiver to amplify big signal. Option B, ability to reject unwanted signal. Option C, ability to convert incoming signal into yes frequency. Option D, ability to reject noise. So correct answer here, option A, sensitivity is defined as ability to receiver to amplify the signal. So correct answer is option A. And next, last question. In radio receiver, varactor diode are used for tuning purpose, demodulation, mixing, none of the above. Option A. So in radio receiver, varactor diode, this is the semiconductor diode, are used for the tuning purpose. So here correct answer is A. In radio receiver, varactor diode used for tuning purpose. Thank you. Thank you very much.